Hello, welcome back to this lesson in algebra where we're solving systems of equations by addition. This will be our last set of lessons in solving systems of equations and our last lesson, of course, in how to do them by addition. So we'll start off with a problem that should be reminiscent of the previous few sections to get our kind of brain working, and then the problem after that will be slightly more complex, and I'll show you how we handle that when we get there. But just keep in the back of your mind that none of them are hard to solve. Right, once we do it step by step. So first equation is 5x minus 6y equals 9. Second equation is 2x minus 3y is 3. So the first thing you ask yourself is, can I add these together and get a cancellation? And you're not going to cancel x and you're not going to cancel y. So what I want you to do is rewrite the system again. 5x minus 6y is 9, and then 2x minus 3y is 3. And then ask yourself, what do I need to multiply one of these equations by to get a cancellation? It's tough to do it with the 2 and the 5, but you can see that 3 times 2 is 6. So what I'm going to then do is multiply this bottom equation, not by 2, because if I multiply by 2, I'll have negative 6. That won't cancel. I have to multiply by negative 2. That'll give me a positive 6, which will cancel. So then I come down underneath, I rewrite the system exactly as I've been doing over and over again, minus 6y. Is 9. Here I have negative 4x. Here I have positive 6y. Here I have negative 6. And now that I know I have a cancellation, I can hit the plus sign and I can actually do the addition. Now the 5x plus the negative 4x is just going to give you positive 1x. The y's are going to totally go away. And on the right-hand side, 9 plus a negative 6 is going to give you 3. So in this case, I don't even need to do anything else. I know that x is equal to 3. I don't have to divide by anything because it was just 1x here anyway. So I'm halfway done. Now I can put this back into any version of the equations I want, but I'm going to go ahead and stick it into this one, just because it's the first one that popped up in my thought process. 2x minus 3y equals 3. And I'm putting x is equal to 3 in. So 2 times 3 minus 3y is 3. So here I have 6 minus 3y is 3. So here I have to get rid of the 6. I'll subtract it. I'll have 3y, negative 3y left over. But 3 minus 6 is going to give you negative 3. And then y, when we divide by this negative 3, will be like this. And then y will be positive 1. So the answer is x comma y. 3 comma 1, that's the solution. Now you see how once you understand what's going on and how we've done it enough times, it's just like candy, it's like clockwork. Okay, we line them up, we try to add them, doesn't work. Okay, we multiply an equation. Okay, now we can add them, and then we just solve, and we plug in, we solve again. We get kind of used to something when we do it over and over and over again. But now I'm going to throw a little bit of a curveball with you. And in the next problem, you're going to see why I've made you copy, or I've asked you, I shouldn't say I made you. I've asked you to copy the system over and over again, even though we're not really making changes to half of it. And I'll also explain why we need a little more steps. So what if we have 2x minus 7y is equal to 10, and then we have 5x minus 6y is 2. So then we ask ourselves, okay, we've got the x's, we've got the y's, that's great. We add the x's together, there's no cancellation. We add the y's together, there's no cancellation. You're like, no problem. All right, what can I multiply this equation by to cancel with the 5? Well, I can't, without dealing with fractions, I'm not talking, you can always use fractions, but I'm talking about whole numbers. What do I multiply? The reason I say that is because if you start multiplying by fractions, you often create even more work than the way I'm going to show you here. Of course, you can multiply by something else to give you a fraction to cancel with the 5. Like you can multiply by 5 halves, for instance, or negative 5 halves. But forget about that. Talking about whole numbers, there's nothing I can multiply by to give me 5, so it's not going to cancel. There's nothing I can multiply this by to give me 6. And if I go to this equation, there's nothing I can multiply this by to give me 2. And there's nothing I can multiply this by to give me 7. So you're stuck until you realize that you don't just have to multiply, or you're not just allowed to multiply one equation by a number. You're allowed to multiply either one or both of the equations by a number. And the numbers that you multiply by don't have to be the same, because remember, all you're trying to do is multiply left and right-hand side by some number to balance that equation. But I can multiply the top equation by 7, and I can multiply the bottom equation by negative 19 if I want. It's totally fine as long as I do it to the left and the